Viewers, Assalamu alaikum wa rahmatullahi wa barakatuhu. First and the foremost thing, Alhamdulillahi Rabbil Alameen. I thank Allah first and then all those viewers who gave positive response to my previous video. I'm grateful to all of you. I was receiving lots of messages regarding when I'm supposed to upload my second lecture. So here I am today with a lecture on carbohydrates for class 11th. Moreover, I would like to inform all the students of 12th class that I'll be coming up with 12th class video lecture soon, inshallah. You have to be very patient for that purpose. Let's get started. Today we are going to take carbohydrates. As far as carbohydrates are concerned, my dear students, remember one thing, that you will be using different terms for the same biomolecule. At certain places you will come across this word called sugar, or will you call them sugars. So sugars, whenever you hear the word sugars, they are related to carbohydrates, or you can say that carbohydrates are also called sugars. And even there is one more term which is called saccharides. You will see this term also used for carbohydrates. Actually, sugars are derived, sugar word is derived from saccharide. Okay, so they are all together meaning the same thing, that is carbohydrates. This thing must be clear with all of you. Number second point is that carbohydrates are the most abundant biomolecules in living cells. Abundant biomolecule in living cell is carbohydrate. So your cells have majority of the proportion of carbohydrate in them. Now, what are they? How can we define them? How can we come to understand what carbohydrate actually is? Earlier it was thought that any molecule which is comprised of carbon, hydrogen and oxygen, they are carbohydrates, and the ratio of hydrogen and oxygen in these molecules must be 2:1. So if a molecule is satisfying this condition, that it's containing carbon, hydrogen and oxygen, where hydrogen and oxygen are in the ratio of 2:1, those molecules were called as carbohydrates. But I will give you one example over here. If you look at this molecule, CH3COOH, you might be knowing this. It's acetic acid. From chemistry, you must be knowing this molecule. Can you count the number of hydrogens present in it? It's 3 plus 1, 4. Can you count the number of oxygens present in it? It's how much? 2. Let us find the ratio between hydrogen and oxygen. It's 2:1 are 2, 2:2 are 4. What is the ratio? 2:1. So this is also a molecule which is containing carbon, hydrogen and oxygen. And the ratio between hydrogen and oxygen is how much? 2:1. But this molecule is not a carbohydrate. It's a carboxylic acid. It means this definition is not a strong way of defining carbohydrates. What is the best way? What is the alternative way of defining carbohydrates then? Another approach towards defining carbohydrates is like this. Now we say, if you take a molecule which is having water molecules in it, like I will take carbon, I'll take n number of carbons, and to this carbon what are attached are n number of water molecules. You call this thing what? You call this thing hydration, something which is attached to water. So if you have hydrates of what? Carbon, you can call them carbohydrates. So this was another way of defining carbohydrates, that they are what? They are hydrates. When you use the word hydrate, you indicate what? Water molecules. Hydrates of what? They are hydrates of carbon. This was another way. This is acceptable and this is valid also. But the most appropriate thing of defining carbohydrates is calling them chemically, they are polyhydroxyaldehydes or polyhydroxyketones. This is the best way of defining a carbohydrate. Now, what does it mean? Polyhydroxyaldehyde or polyhydroxyketone. What does it mean? I'll be drawing a molecule on the board. You just observe it carefully. So I'll be drawing like this. I'll be taking like, what are these? Right now I have made 1, 2, 3, 4, 5. How many carbon atoms? 6. Now over here I'll place C double bond OH. Can you guess something about it? Then I am placing H over here, OH over here. Then I am placing OH over here, H over here. Then H, OH, H, OH. Over here I write down CH2, OH. Examine this molecule. Examine this compound. What is it having? It's having many OH groups. What are OH groups according to chemistry? They are what? Hydroxyl groups. So it's containing many hydroxyl groups. Can you call it polyhydroxy then? Yes, we can call it polyhydroxy, containing many hydroxyl groups. What is it also having? It's having an aldehyde group. Which group is this? This is aldehyde group. Which functional group is this? This is C double bond OH. This is an aldehyde group. So this is a compound which is having many hydroxyl groups, OH, 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 and it's having which functional group? Aldehyde group. This compound is a polyhydroxyaldehyde. This is actually a carbohydrate. Similarly, let me give you one more example. I'll be drawing now like this. CH2OH, then I'll go like this. C double bond O, then I'll go like C, H, OH, C, H, OH, C, H, 1, 2, 3, 4, 5, OH, and then C, H, 2, OH. See? 1, 2, 3, 4, 5, 6 carbon atoms. And what else you have in this compound? You have many hydroxyl groups like this. So many hydroxyl groups. And you have which functional group in this molecule? You have a ketonic group. Over here it was an aldehyde group, C double bond OH. Over here you have a ketonic group. What is this compound? A polyhydroxy ketone. This is also a carbohydrate. So technically, molecules which have many hydroxyl groups, which have aldehydic functional group or ketonic functional group, they are actually your carbohydrates. And do you know this molecule? You know both of these molecules. You might be knowing about them. This is actually your glucose molecule, and this is your what? This is your fructose molecule. If you look at their molecular formula, it's like C6H12O6, and this is also C6H12O6. Look at this. They satisfy this thing also. Ratio of hydrogen and oxygen is 2:1. If you calculate the ratio for hydrogen and oxygen, it will be 6 1 are 6, 6 2 are 12. Ratio will be 2:1. For this, it's also 2:1. And if you look at this thing, they are actually hydrates of carbon. They are actually what? Hydrates of carbon. And if you look at this definition, they stand well for both polyhydroxyaldehyde, polyhydroxyketones. These are the molecules which are actually what? They are actually your carbohydrates. So you came to understand what carbohydrates are. They are polyhydroxyaldehydes or polyhydroxyketones. As per the nature of the functional group which is present in carbohydrate, we can categorize carbohydrates into two broad groups. So this division, this classification is based upon what? It's based upon the nature of functional group present. If the functional group is an aldehyde group, if the functional group is like this, C double bond OH, if this is the functional group, what do you call this group? You call this group aldehyde group. If the functional group which is present in a carbohydrate is an aldehyde group, then you call this carbohydrate an aldose. What do you call it? Aldose. And if the functional group is like this, C double bond O, which is this group? This is a ketone group. If this functional group is present in the carbohydrate, then that category of carbohydrate is called, you can guess it, it's called ketones. So you have two classes of carbohydrates. One are aldoses, another are ketoses, and they differ from each other in terms of what? In terms of the functional group. If you find an aldehydic group, you call them aldose. If you find a ketonic group, you call them a ketose, which is the example for an aldose you came to know right now. It was what? It was glucose. And which is the example for carbohydrate under ketose? It is fructose. So you got to understand two examples over here. One was glucose, another is fructose. Both of them are carbohydrates. Both of them you use the word sugar for them. You can call them what? Sugar. So they are what? Sugars. Or you can use the word saccharides for them. So for the same carbohydrate you can use these words sugars. For the same carbohydrate you can use the word saccharides, because now ahead we will classify carbohydrates based upon what? Based upon sugars or their saccharides. But this is the basic classification of carbohydrates, and basically carbohydrates differ from one another in terms of the functional group, and you will only find these functional groups, main functional groups, aldehydic group and a ketonic group. And what is this category called? Aldose, and that category is called ketose. One representative from aldose is glucose. One representative from ketose is fructose. Now understand classification of carbohydrates in detail. The way I am going to classify carbohydrates, that will help you to remember them for NEET and AIIMS examinations as well. So try to be attentive. You know that there are different ways of classifying things. Like you can classify things on the basis of physical properties. You can classify things on the basis of chemical properties. Let us say, for example, initially we will take physical properties into consideration. Here I'll be taking properties like molecular weight into consideration. I'll be taking properties like solubility in consideration. Solubility in which solvent? I'm taking solubility in water into consideration, and I'll be taking one more physical property into consideration, that is taste. So depending upon these three physical properties about the taste of carbohydrate, molecular weight of the carbohydrate, solubility of carbohydrates in water, we can classify them into two categories. Number one, with those which have got sweet taste. These are having low molecular weight, and they are going to be what? Soluble in water. So one set of carbohydrate has this set of physical properties. They are what? They are sweet to taste, they have low molecular weight, they are soluble in water. Other set has what got? They have got opposite characteristics. They are what? Tasteless carbohydrates. They have got high molecular weight, and they are insoluble in water. Try and understand. So one set of carbohydrate has got this set of physical properties. Another category of carbohydrate has this set of physical properties. These are called, this category is called saccharides or sugars. They are very basic. They are very basic in nature. And these are actually long chains, very, very long chains of saccharides. That's why you use the word polysaccharides for this category. So you have right now, I give you two categories of carbohydrates. One is the saccharide sugar category, another is the polysaccharide category. The basic difference between these two categories is in their physical properties. This set of carbohydrate, they are sweet to taste, they have low molecular weight comparatively, they are soluble in water, and these ones, they are big chains, big polymers of saccharides actually. That's why you use the word polysaccharides. And they are tasteless, high molecular weight having compounds, and they are insoluble in water. Now, if you look at saccharides, you can classify saccharides into three categories further. They could be monosaccharides. They could be disaccharides. Or these could be oligosaccharides. You have this term saccharide. You don't need to get confused with it. Saccharide indicates what? Sugar. And you know some sugars also. You know glucose and fructose till now. Okay. So I give you how many categories overall? You have overall 4 categories. See? Number 1, monosaccharides. Number 2, disaccharides. Number 3, oligosaccharides. Which is number 4? Polysaccharides. We have to discuss about each category in detail. Now, let us try and understand right now, at least let us understand about their composition, about the basic difference between them. Monosaccharides are those which are just a single sugar. So, they are what? They are simplest carbohydrates. They are simplest carbohydrates. Very simple carbohydrates are called monosaccharides. They are just one sugar. Just one sugar. Reference example you can take is glucose, C6H12O6, which you saw earlier. Another reference example which you can take for monosaccharide is what? Fructose. These two differ from each other only in terms of their functional group. Glucose is an aldose, fructose is a ketose. But both of them are simplest carbohydrates and they fall in the category of monosaccharides. And there is one more thing you can remember about these monosaccharides are that they cannot be further hydrolyzed normally. When you talk about normal monosaccharides, they cannot be further hydrolyzed into simpler monosaccharides. Okay, so these are going to be what? These monosaccharides are actually the building blocks of your carbohydrates. So what is going to be the building block of the carbohydrate? It's the monosaccharide which is going to be the building block of your carbohydrates. Now, if you look at disaccharide, what are they going to be? They are going to be such carbohydrates which contain how many sugars? They contain 2 sugars. So, it will be something like this. 1 sugar, say for example, I will be taking glucose attached to 1 more glucose. What is this? It's not 1 glucose. Over here you had 1 glucose. Now you have 2 glucoses attached to each other. It doesn't remain monosaccharide now. It becomes disaccharide. What is the name of this disaccharide? It is maltose. Similarly, I will give you yet another example of a disaccharide, that is sucrose. So maltose is an example of a disaccharide. Sucrose is an example of a disaccharide. Maltose is made up of 2 glucoses. Sucrose is made up of glucose and fructose. So they differ also. Right now you just remember their names. Ahead I will be telling you about the differences between maltose and sucrose. So right now you must remember at least that maltose and sucrose are disaccharides. They are made up of 2 sugars. Okay. Now one thing which you can remember over here is the bond which connects the 2 sugars. What is this bond called? This bond is called, it's called glycosidic linkage, or you can call it a glycosidic bond. So which is the bond which you will find in carbohydrates? In carbohydrates, if there are sugars which are connected to each other, the bond which connects the 2 sugars is going to be which bond? It's always going to be a glycosidic bond. In each biomolecule, you will find different types of bonds. Okay? For carbohydrates, you have to remember this linkage. The name of the linkage is glycosidic linkage. Now, what about oligosaccharides? What about these? These are made up of 3 to 10 sugars. So if you have 3 sugars attached to each other, oligosaccharide. If you have 4 sugars attached to each other, oligosaccharide. If you have similarly 6 sugars attached to each other, oligosaccharide. If you have 10 sugars attached to each other, still you call it oligosaccharide. So 3 sugars attached to each other are oligosaccharides, or 3 to 10 sugars attached to each other are oligosaccharides. Let me give you example. The best example is raffinose, in which you have 3 sugars attached to each other. So they are not only glucose. In raffinose you will find glucose, galactose and fructose. You don't need to remember. At least remember that raffinose is basically having how many monosaccharides? 1, 2, 3. That's why it falls in which category? Oligosaccharide. Let me give you one more example. Another example is statiose. Statiose has 4 sugars. It also has glucose, galactoses and fructose. But how many total? 4. So raffinose and statiose are the best examples for oligosaccharides. Raffinose contains 3 sugars. Statiose contains 4 sugars. Similarly, those carbohydrates which have 3 to 10 sugars, they will fall in which category of carbohydrates? They will fall under oligosaccharides. So monosaccharide, simple, just 1 sugar. Disaccharide, 2 sugars. Oligosaccharides, 3 to 10 sugars. The bond which is used for connecting one sugar with other sugar, say for example glucose with glucose, the bond is glycosidic linkage. Example for monosaccharide is glucose and fructose. Example for disaccharide is maltose and sucrose. Example for oligosaccharide is raffinose and statiose. Now let us try to understand something about polysaccharides. I'll wrap this portion so that I'll give you an idea about polysaccharides. So polysaccharides are what? Can you guess? They are going to contain more than 10 sugars. So if you have a long chain in which you will find 10, 20, 30, 40, 50, 60, thousands of sugars attached to each other. Even you will find branching like this. You will not find only a long chain like this. You will find at certain places that this chain of sugars is showing branching. Like this is the chain. Say for example, it's glucose, 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 glucose. And at certain places it's branching like this. You have a branch coming. Okay. Again now, suppose it's branching over here also. So this branched complex thing is called what? Polysaccharide. Example of such a compound which shows this type of structure is starch in plants and glycogen in animals. Starch and glycogen are the 2 examples of polysaccharides, which are actually long polymers, long chains of glucose. And they are not only chains, they have even branchings at the different places. So this is the way in which carbohydrates are classified, and we are supposed to discuss about each category. We have to take monosaccharides, we have to discuss them in detail first, we have to understand their physical and chemical properties in detail, then we will go to disaccharides, then we will study about oligosaccharides, and at last we will take up these polysaccharides. Once we will discuss all these categories, then our carbohydrates are complete. Out of the 4 categories, which is very important to understand first of all is monosaccharides. Before taking that, let us quickly revise it again. So I have classified carbohydrates based on physical properties. 3 properties I have taken into consideration: taste, molecular weight and solubility. As per these, certain have sweet taste, low molecular weight and are soluble in water. That category we have called saccharide or sugar. Certain others were what? Tasteless, insoluble in water, and having high molecular weight. That category we call polysaccharides. Now saccharides, we further classified them based upon the composition. You can remember, like we have devised this on the basis of what? On the basis of composition. We have divided saccharides into monosaccharides, disaccharides and oligosaccharides. Monosaccharides, just 1 sugar. Disaccharides, 2 sugars. Oligosaccharides, 3 to 10 sugars. Polysaccharides, more than 10 sugar. And which is the bond? That is glycosidic linkage. Sometimes you are asked this basic question, what are simple carbohydrates and what are complex carbohydrates? That's not anything different. Let me make you understand that thing also. For that purpose, I will rub off this particular part of the board. Okay, I'll make you understand that thing over here. Okay, so if you talk about monosaccharides and disaccharides, these two categories form simple carbohydrates. It's very simple, but sometimes you are asked. So monosaccharides and disaccharides form simple carbohydrates, whereas if you look at what? You're left with two other categories. If you look at oligosaccharides and polysaccharides, if you look at these two categories, if you look at oligosaccharides and polysaccharides, they are called complex carbohydrates. Do remember this also, because sometimes you are asked this in competitive examinations. So monosaccharides and disaccharides fall under simple carbohydrates. Oligosaccharides and polysaccharides fall under complex carbohydrates. Let us now discuss monosaccharides in detail. Let's discuss the structure of monosaccharides in detail. We will not only discuss their structure, we will be discussing all the properties of monosaccharides. So till now you know that monosaccharides are what? They are the simplest sugars. So they are simplest carbohydrates. They are simplest carbohydrates. What do you mean by simplest carbohydrates? You cannot further hydrolyze them. You cannot further break down them into simple monosaccharides. And another thing is about their general formula. You have to remember their general formula. It's very important. General formula is CnH2nOn, where N is what? N is the number of the carbon atoms. Okay? N is the number of carbon atoms. So you have N number of carbon atoms, 2n number of hydrogen atoms, and N number of oxygen atoms. And N always ranges from 3 to 7. So in monosaccharides, you'll be having carbon atoms either 3, 4, 5, 6 or 7. Okay? Another thing you know about monosaccharides is that they are what? They are either polyhydroxyaldehydes or they are polyhydroxyketones. Because you have seen there are two categories. We have got these two categories, aldoses and ketoses. Both of them were actually what? They were actually types of monosaccharides. Now, we can further, you can further classify monosaccharides. We can further classify monosaccharides. They can be classified. So, I am writing monosaccharides can be classified as, you will have following classifications. Now I will give you the classifications. But your question must be that on what grounds, on what basis we are going to classify monosaccharides. We will be classifying them on the basis of number of carbon atoms present. So, depending upon the number of carbon atoms which are present in a monosaccharide, we have following types of monosaccharides. Okay, I'll be giving you these types over here. So, the first category is going to be trioses. Trioses are going to have how many carbon atoms? They are going to have 3 carbon atoms in them. Okay, so 3 carbon atoms are present in some monosaccharides. You call those monosaccharides trioses. The best example of a triose is, so I'll give you examples over here. So this side is for examples. For this, you have 2 examples. One is glyceraldehyde. This is very important to remember. Another is dihydroxyacetone. These 2 are the examples of monosaccharides, correct? But of which type? Trioses. Because both of them have how many carbon atoms? 3 carbon atoms. Very simple. Now let us further understand. Let us understand again. Second type is, you can guess, Tetroses. Why Tetroses? Because they have got how many carbons? 4 carbon atoms. That's why the nomenclature is Tetroses. As far as the examples are concerned, I'll give you 2. One is erythrose. Another is triose. So you got 2 examples for Tetroses. Let us come to the third category. Third category is pentoses. Very simple to guess. Pentoses having how many carbon atoms? 5 carbon atoms. Let me give you 2 examples for pentoses. One is ribose, which you know from RNA. Another is deoxyribose, which you know from DNA. So these 2 sugars are present in your nucleic acids. Inshallah, we'll see that ahead. Next is the fourth category. They are hexoses. Okay, hexoses have how many carbon atoms? 6 carbon atoms. Okay, any representative example? Yeah, we have seen this right now. It was glucose. I have shown you the open form also. There I counted 6 carbons. Do you remember? 6 carbon glucose, 6 carbon fructose. So glucose and fructose you are getting now. Glucose, fructose are both monosaccharides. Of which type? Hexose. Why hexose? Because they have got how many carbons? 6 carbons. And why is glucose called an aldose? Because it has aldehyde functional group. Why is fructose called a ketose? Because it has a ketonic functional group. Okay. Number 5th and the last category is the heptoses. Heptoses have 7 carbons. Some of the examples I'll be giving. You have a compound which is called pseudoheptulose. It contains 7 carbon atoms. You have a compound called glucoheptose. It contains 7 carbon atoms. So right now we have seen different types of monosaccharides. One type was already known to you, that was aldose and ketose, depending upon whether a monosaccharide has an aldehyde group or a ketonic group. You have to remember monosaccharides are basically carbohydrates. Now you further can classify monosaccharides into 1, 2, 3, 4, 5 classes. These classes differ in what? They differ in their number of carbon atoms. In one category you have 3 carbon atoms, in another category you have 4 carbon atoms, in another category you have 5 carbon atoms, in another category you have 6 carbon atoms, in another category you have 7 carbon atoms. Accordingly you have the names. 3 carbon atom monosaccharide is called triose, 4 carbon atom monosaccharide is called tetrose, 5 carbon atom monosaccharide is called pentose, 6 carbon atom monosaccharide is called hexose, 7 carbon atom monosaccharide is called heptose, and I have given you some examples. Let me help you remember the names of these examples. Glyceraldehyde, dihydroxyacetone. You will find these molecules once you will start studying glycolysis with me, inshallah. Erythrose, triose, 4 carbon, both. Ribose, deoxyribose, 5 carbon, both. Ribose you will find in RNA, deoxyribose sugar you will find in DNA. Glucose and fructose, Both of these we have discussed earlier when we started this lecture. Heptulose and glycoheptose. Now I'll be showing you some of the open forms or structures among these. I'll be drawing some out of them along with you to prove to you that all of them are polyhydroxyaldehydes or polyhydroxyketones. Students, let us draw some open chain, or you call them straight forms of monosaccharides. This will help you in AIIMS and other examinations also, because you must have a strong hold on monosaccharides. We'll be drawing some open chain forms, and you must be aware about different conformations as far as chemistry is concerned. You know about open forms, you know about closed forms. Inshallah, I'll be showing you open as well as closed forms of monosaccharides. Right now, we'll work with the open forms, or which you call open chain forms or straight forms. Let me draw some monosaccharides, then we will analyze what category they belong to. I'll be starting with CH2OH, C double bond O, CH2OH. So this satisfies that requirement. Hydroxyl, hydroxyl, polyhydroxy, and it has got a ketone group. So it's going to be what? A carbohydrate or a monosaccharide. I'll be drawing another like this, C double bond O, H, then CHOH, CHOH, C 1, 2, 3, 4. Okay, I'll go with 5 carbons. OH, CH2OH. So over here I have done 1, 2, 3, 4, 5 carbon compound. Okay. Let me give you one more example. I'll go like this: CH2OH, C double bond O, CHOH, 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 1, 2, 3, 4, 5, and last one, CH2OH. Let us start analyzing them. So this is how many carbon compound? It has 3 carbon. This has 1, 2, 3, 4, 5. It has 5 carbons. 1, 2, 3, 4, 5, 6. It has got 6 carbons. All of them are what? Polyhydroxy. You can see everywhere you have hydroxyl groups. You have everywhere hydroxyls. You have in this you have ketonic group. In this you have aldehyde group, and in this you have ketonic group. So all of them are carbohydrates. Very good. All of them are monosaccharides, the simple carbohydrates. Now you can see they are 3 carbon compound. This is 5 carbon compound. This is 6 carbon compound. Accordingly, you can name it. This is what? Which class? It's a triose. This is a pentose. I'll make N proper. Pentose. This is a hexose. Can you guess the name? This one is dihydroxyacetone. This is your well-known ribose. This one is your well-known fructose. Okay, my dear students, sometimes these open chain or straight forms which I have drawn right now on the board, they are also called, I'll write down here, they are also called Fischerprojections. So you have different terms for the same structure. Call them Fischerprojections, call them open chain forms, or call them straight forms. We can practice one more thing on this board right now. Dihydroxyacetone belongs to which type of monosaccharide? Is it aldose or a ketose? It's a ketose because of this ketonic group. This is aldose. And what is this? This is ketose. Very good. So we did a lot of practice over here. There's one more thing that 5 carbon and 6 carbon monosaccharides. If you talk about this medium, I'm talking about aqueous medium, wherever water is present. If you take in aqueous medium, these conformations, these forms are actually unstable. Okay, which forms? These open chain forms are unstable. When you will find these monosaccharides in aqueous medium, you will not find them in open chain forms. You'll find them in what? You'll find them in closed ring forms, which are called Haworth projections. I'll show you these projections, or I'll show you these closed ring forms ahead. You must have an idea about these open forms as well as closed forms of monosaccharides. Open forms are called Fischer projections and closed forms are called Haworth projection. Let me show you that next. You know that monosaccharides have which forms? They have open forms which you call straight forms, and they were represented by which projection? They were represented by Fischer projection, which I have shown you earlier. Okay, the open forms of monosaccharides can be represented by means of Fischer projections. Then I told you that if you talk about a 5-carbon monosaccharide or you talk about 6-carbon monosaccharide, say for example if you talk about ribose or hexose, they are not stable under aqueous medium. You will not find them in which form? You will not find them in open form in aqueous medium. They are unstable in that form. So they take a closed form, or what you call a ring form. There are broadly two types of rings which are formed. 5-carbon compounds form the furanose rings. They form which rings? Furanose rings, which are pentagonal, having 5 sides. And these 6-carbon monosaccharides, they form pyranose rings. This is interesting, which are hexagonal. Now the question arises, how do these open forms get converted into these ring forms? So I was earlier drawing something like this, if you remember. Now these forms are going to change into something like this. This form we are going to get. This is an idea, elementary idea. So this was which form? Open form. Now you have to get which form? Closed form. How are these open forms getting converted into closed form? Open form representation is called what? Fischer projection. Closed form representation is called which projection? It's called Haworth projection. Let me write down over here. So closed form or ring form, they are represented in Haworth projections. You need to remember them in contrast so that you will memorize. So open forms are represented by Fischer projections. Closed forms are represented by Haworth projections. Now the question arises, how do these forms are produced? Let me make you understand this. For this you must have a strong hold on chemistry. In chemistry, we are being taught that whenever you take what? An aldehyde. It reacts with what? Alcohol. And it results in the formation of a compound which is called hemiacetal. Let me show you in detail. You need to have a very strong hold on chemistry to understand this, but I'll try to make it as simple as possible. I will make an aldehyde compound. Suppose I am drawing over here C, double bond O, H and R. R is the chain which is attached with the aldehyde group. So this is an aldehyde, if you agree. Now to this aldehyde, we'll make it react with an alcohol. Let us make a representative alcohol. I will write down R-OH. I have a dash over here so that there will be a distinction between this chain and this chain. So these two will react. In aqueous medium, they react. And they result in the formation of what? They result in the formation of a hemiacetal, which looks like this. Hemiacetal looks like this. It's like this. R, oh sorry, it's not green, it's blue. I've used blue color. So it's like this. R dash, then O. Then you have the component from the aldehyde, that is C, H. You need to follow this. Then R and OH. This compound is the hemiacetal. Okay. Same is happening when this open form is getting converted into closed form. What is happening in the monosaccharide? Its aldehyde group is reacting with any of the alcoholic groups and a ring is formed. And that ring structure is definitely going to be called what? It's going to be called hemiacetal, because it no more remains polyhydroxyaldehyde or ketone. It becomes hemiacetal. Okay. Similarly, we have been taught in chemistry that alcohols also react with ketones, and they give hemiketals. Let me show you. I will take an alcohol for, say for example, over here, R, I'll give double dash, then OH, okay, and then I will take a ketone over here. I hope you agree that this is a ketone. Look at this, C double bond O and R. So this is a ketone, you agree? You have C double bond O and you have two R chains. One is R dash, another is R. And over here I have taken an alcohol, R double dash OH, just to make a distinction between the chains. So one chain is R, another is R dash, another is R double dash. This will make us easy to understand the hemiketal. They react with each other and they result in the formation of what? Hemiketal. Let us look at the structure of the hemiketal. It will be like this. R double dash O out of alcohol, and then you will be having C R dash OH. What is this? This is a hemiketal. Why are we understanding about hemiacetals and hemiketals? You have to understand that when open chain forms are getting converted into closed forms, what is actually happening to these monosaccharides? They are getting converted into hemiacetal forms and hemiketal forms. When an aldehyde group of a monosaccharide reacts with its alcoholic group, it results in the formation of a hemiacetal. When the ketonic group of an monosaccharide reacts with its alcoholic group, it results in the formation of hemiketals. And these hemiacetals and hemiketals, in case of monosaccharides, both of these, in case of, so I'll write down over here, in case of monosaccharides, they are closed rings. Okay, those rings are then represented by Haworth projections. I will show you an example of a Haworth projection now. For reference, I'll be taking an example of a pentose. So over here, I'll be drawing a pentose. So let you guess which pentose it is. Let me make it interesting. So this is C double bond OH. Then I have CHOH. Then I have CHOH. Practice. Practice makes you perfect. So it's H. And then I'll show OH with some other color. Do you remember that aldehydes and alcohols react to form what? Hemiacetals. Okay, that's very important. So you have CH2 and OH. Okay. Can you guess which sugar it is? Which monosaccharide it is? It's having, let's label the number of carbons. 1, 2, 3, 4, 5. It's having 5 carbon atoms. And it's an aldehyde group. It is aldose. It's pentose. But what is the name? This is actually ribose. And which form I have made? Open or closed? This is open form. Okay. And can you tell me what is this projection called? It's called which projection? Which projection it is? It is Fischer projection. Okay. Now what will happen in aqueous medium? I have told you earlier, in aqueous medium what happens? Aldehyde and hydroxyl. So in this case, it's this hydroxyl group which is attached to carbon number 4. They react in which medium? Aqueous medium, and they result in the formation of a cyclic ring. Look, I'll show you that ring which is being formed. So you'll have oxygen, and then you will have carbon, 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 carbon. I will give you an estimation of these carbons. I'll try to make it look more appropriate. I'll place this oxygen over here like this so that you will get a proper pentagon. Okay? See. Now which carbon is this? Which carbon is this? Which carbon is this? Which carbon is this? And where is the 5th carbon? This is carbon number 1. This is carbon number 2. This is your carbon number 3. This is your carbon number 4. And carbon number 5, this one, is here. CH2OH. It's over here. So this is your carbon number 5. So these are numberings. I am encircling them so that you will not get confused. What is this encircled number? It's the carbon number. Carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. Over here they were like this. Carbon number 1, carbon number 2, carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. So you got it absolutely converted into a cycle, whereby these 4 carbons become the part of the ring, hydrogen becomes the oxygen becomes the part of the ring, and this fifth group, it becomes attached to the ring. And if you want to complete, you want to show rest of the H's and OH's, it will be like this. Over here you will be having H, and downwards to this carbon, what will you find attached? You will find attached an OH. Then you will have over here H and OH. Carbon number 3, it's H and OH. Carbon number 4, it's H and CH2OH. CH2OH we have shown, and this is its H. I can simplify this. You are not supposed to show carbons because the corners will represent the carbon. So I will be showing it like this. If you want to simplify it, you can show it like this. Oxygen, which is now the part of the ring. Then you can show like this. This is the simplified version of the same ring. Here these corners represent your carbon number 1, 2. So this corner represents carbon, this represents carbon, this represents carbon, this represents carbon. And then you can show rest of the things like this. So you will be showing like this, CH2OH. And then you will be showing like this, H. This is H, OH, H, OH, H, and the other OH. So they are both same. And which form is this now? This is no more the open form. It's now a ring. So this is your closed ring form of ribose. Okay. This was which projection? Fischer projection. This is called Haworth's projection. So the configuration you are showing by means of which projection? Haworth projection. So this is Haworth projection. This is Fischer projection. And now you don't have a monosaccharide in the form of aldehyde anymore. Now it's what? It's a hemiacetal, which I discussed in the previous clip. So my dear viewers, this was all I had for you people in this video lecture. Inshallah, we'll meet again on YouTube, and I'll be taking up isomerization in monosaccharides. On your textbooks, you will find D sugars, L sugars, you will find dextrorotatory sugars, levorotatory sugars, etc. You will find different types of isomers which are possible in case of monosaccharides. Because that's a very important topic, I'll be taking that inshallah in video lecture 3rd. So till then, you are supposed to like, share and subscribe my channel so that I can reach to more and more learners. May Allah keep you safe and healthy. Take care. Fi amanillah.